Right, so yes, I'm Marc Gravell, and I'm going to be talking today about gRPC. And it's actually really good timing today because quite a lot of the things that I'm going to be talking about today tie into the .NET Core 3 RTM yesterday. So it's just kind of a really good time to kind of look into this. In fact, I've been meaning to look at gRPC in earnest for many years, and it wasn't appetizing until the bits I'm going to show you today. And now that that's kind of available, that's kind of certainly why I've got really interested in it as a space. This kind of feels like the time when it kind of makes gRPC much more approachable in .NET. So, first, who am I? Why am I here talking to you about this? So, as Dan said, I work at Stack Overflow on the architecture team, and my particular interest is in anything to do with moving data around. So I do a lot of work with databases, with things like Dapper, or NoSQL databases like Redis, anything to do with moving things around. So Protobuf-net, Protobuf, for those who haven't heard of it, and I'll cover it in a bit, is Google's serialization format. And in particular, what really kind of interests me is things to do with meta-programming. So that's essentially programs writing themselves at runtime to work as best as they can on your system. And I've been kind of working in spaces like Protobuf for well over 10 years now. So yeah, this is kind of why it's interesting to me. So what we're going to look at today, and I need to start my timer. I always forget to start my clock, and then I've got no idea where I am. There we go. So what we're going to look at is, first of all, what the hell is gRPC and why would you want to use it? What scenarios would you want to use it in? We'll have a look at that. How could you use it today? And there are strengths and weaknesses to any technology, and it's kind of important to know kind of what it's good at, what it's not good at, to kind of see how it fits into your scenarios. So we'll have a quick look at that. Now, as I said, what's really interesting to me is what's new in gRPC in .NET Core 3. I mean, gRPC is not a new technology. It's been around for a good many years, but if you're kind of listening on Microsoft Space or on Twitter or anything else, you'll have seen a lot of people kind of talking about gRPC recently, and so there's a question there. Why is that? Why is it news now when it's kind of been around for ages? So we can look at that, and then. There's even more things. So there's kind of two sets of things that are new in kind of gRPC, and I'll kind of introduce those separately, and then we'll summarize. Now the good thing is we've got quite a little bit of time today. So what we'll probably do is kind of look at how we'd use it today, as far as kind of what it is and how we'd use it today. Kind of in the first session, then take a bit of a break, and then we'll come back and look at all the new stuff in .NET Core 3. Kind of after the break. That makes sense? Cool. So, what the hell is gRPC? It's all about services, really. These days, everything is services. Everything talks to, there's no, back 20 years ago when I was kind of starting programming, monoliths were quite common. You just don't have monolith applications today. Everything is multiple systems talking to each other. Whether that's a browser talking to a server, but these days a lot more. You also got it's not just a client talking to a server. These servers they have microservices, and everything's talking to each other, to the point where you can't change the heating in your house without talking to 17 computers. So gRPC is obviously it's an RPC, so remote procedure call technology by Google. But as Dan said, the G doesn't stand for Google. The G stands for gRPC. In all those fun ways. So gRPC, it's all about making a technology available to kind of make this stuff easy and manageable so that you as a programmer can focus on the bit that's actually interesting and relevant to your business. So you're not spending all your time writing I/O code, socket code, all of those kind of things. Instead, you can kind of focus your time actually, selling things or whatever it is you do in your day job. to pay the bills. So, like I said, it's an RPC stack developed and used by Google originally, and it was open sourced in 2015. It's not new at all, and in fact, Google. I'm pretty sure Google were using it for a long time before that. I think it kind of goes back to the early days of kind of Protobuf. It's just that until they actually had all the other bits in places like HTTP2 that we'll come on to, it really didn't make sense to kind of open source kind of the rest of it, because it just didn't have anywhere to any kind of protocol to sit on top of. So one of the things it's aimed to do is to be kind of platform independent. Obviously, you've got companies like Google. They're kind of dealing with wide ranges of infrastructure on multiple platforms, but that applies to us as well. We might have some of our stuff in .NET, some of it in Go, some of it in Java. So having a technology that can reliably talk between all of those things is a very good idea. And when I say reliably, you might think, well, sure, JSON's pretty reliable. If you really, really want to watch a programmer cry, ask someone like James Newton King or Kevin Montrose how dates are expressed in JSON. Because, yeah, in fact, I think just asking them the precision there's. I did some work on Jill, and that's really kind of Kevin Montrose's thing, but I know just how painful some of those things are, and there's like 17 different ways of expressing anything, and none of them are compatible. The idea is to make something that can work reliably between systems. And high performance. Now this matters a lot. It used to be, you're talking, if you're just talking between two nodes, so maybe you're talking from a client to a server. It'd be nice if we minimize the amount of stuff that we transmit, but we can always compress it. Serialization and deserialization, that's just a thing that happens, and we don't need to worry about it because computers are fast. That's nice in principle, but these days, when we're talking about things like microservices, and we've got data bouncing from between however many layers in your application, or just because you're dealing in a very, very high throughput scenario, it turns out that performance really does matter. And if you've ever kind of looked at a SOAP message or a JSON message as we're kind of passing things around, there's an awful lot of cruft in there. Just kind of verbose stuff that is designed really to be human readable. When you're bouncing stuff between microservices, they don't care that it's readable. They just want to get stuff through as fast as possible. They don't want to spend all their time parsing, white space and reading a 20-character name or a 80-character name if it's got an XML namespace. Resolving that string, decoding it through UTF-8 or UTF-16 or whatever it is. Doing 16 other steps. It's designed not to kind of do all those cruft things and be as efficient as possible, so that the code can just read your data or write your data really, really fast without having to kind of do all those things. It's also designed to be dense on the actual wire. So it uses, I'll come on to it, but it uses Protobuf normally, which is Google's binary serialization format, instead of JSON or XML. So that means that not only is it cheap to process because we're not kind of encoding all those things, but because it's nice and small in the first place, we've avoided both the CPU cost at the sender and receiver, but also the network cost of sending this huge chunk. So like I say, it's based on protocol buffers, and it is unashamedly tied to HTTP2. So that's kind of why it didn't really make sense before those things were in place. So HTTP2, for those, obviously it's the kind of successor to HTTP 1.1, but it's got a lot of things in there to do with how it encodes things like the HTTP headers and the actual framing protocol that allows you to do a lot of things that you would normally associate with, say, WebSockets. Or those things are now directly in the protocol itself. So it kind of gives it as an RPC technology. It allows it to do kind of a lot of things to do with moving data around without lots and lots of overhead. Why would you want to use it? Now, obvious answer to this is if you're kind of talking to a service that is already GRPC, then sure, you're going to have to use it. That's fine. Read the docs, find out what's involved, use the tools, get it done. But part of what I'm kind of here to kind of sell essentially to you today is that I think it's still a good choice, even if you're not talking to a service that's GRPC. I'm not saying it's the solution to every problem. It's just a tool, and you're allowed to use many, many different tools, the right tool for the right job. So hopefully I can kind of in this session kind of give you a feel for what gRPC is good at and kind of what it can do for you. So I think it's a really good choice just for your own, whether they're your in-house systems or talking between teams, any scenario really where you just want efficient, robust, well-tested stuff that's going to move your data around efficiently without you having to do all the hard work. There are other tools that do that. I'm just saying this is one of them, and it's one you should consider. As I've kind of emphasized, I think it's kind of a really good fit for microservices, and I think that's really the key point, kind of why it's making kind of a lot of noise at the moment, and indeed why Microsoft have invested some time into it. So I'll come on to it in a bit, but yeah, Microsoft are doing a lot of work in gRPC in .NET Core 3, that's no secret. So that's where kind of all the noise is at the moment. So, like I said, usually gRPC is used with Protobuf. It's not actually, you don't need to use gRPC with Protobuf, but really to kind of understand where it's coming from, we need to understand Protobuf. But if you want to, just to say, you can, the actual payload, the actual bucket of data that you're moving around from places, that's actually just an opaque blob, just in the implementation detail. So if you really, really want to, you can use gRPC with things that aren't Protobuf. It's just that most of the time, if you're talking about gRPC, you're also talking Protobuf. So, also want to mention Protobuf. What the hell is it? So I've kind of covered a few bits of this already, so we won't be long on these. But yeah, Protobuf is the binary serialization protocol designed by Google. There is actually a JSON variant of Protobuf. That's not the one that's usually in use with gRPC unless you're in some kind of weird, bizarre fallback mode or something. So yeah, don't be confused if you look at a Protobuf example and it's showing JSON, it's usually the binary format. So this goes much older in terms of the public visibility, back to 2008. And again, it's platform independent, all the exact same things that I was talking about before. I kind of covered this already. So it's low CPU to actually do the processing and low bandwidth for the actual transmission. So it's kind of great for moving data around. And it's version tolerant. So when people, when I mentioned to people, oh yeah, it's a binary serialization format that you can use in multiple technologies, including .NET. And when I say that, people tend to think, oh yeah, like binary formatter. No, please do not use binary formatter in current year. It is a horrible thing, and it will. It's not a question of will it hurt you. It's just a question of when will it hurt you. Binary formatter is well known for being very, very version intolerant as you either refactor your types or move them around or change technologies. Basically, so don't confuse the two. The fact that it's a binary serializer in this case just means it's serializing data into a non-text format. It doesn't mean it's doing the thing that binary formatter does. Okay, so it's the good kind. There you go. So, how would you use gRPC today? Now, the good news is, because we've got plenty of time today, I can actually come to demos instead of looking at slides. So, and I should have said, all of the slides here and the code is all available online on GitHub under the Protobuf-net repo, and there's a Protobuf-net gRPC. So I've got a Visual Studio window here. I should emphasize most of the things that I'm going to show will also work perfectly fine at the command line. It's just for my convenience using Visual Studio. So what would you do today if you were trying to work with gRPC? So the first thing is, as Dan mentioned, if you're going to start gRPC today using kind of the Google approach, the first thing they'd start talking about is define your .proto. So what on earth is .proto? So this is a DSL, so it's a domain-specific language that basically allows you to define your data contracts and your service contracts. So it's what the data is and what services are available. So that isn't very complicated. So what I've got here is a project. That's nice and big, I hope. Yep. And in fact, if you normally if you just do, I think in the current version of Visual Studio, there's actually some GRPC specific templates you can now use. I've set this up manually because I tend to do things with like version placeholders, so don't worry about that. But the interesting bit in here is that I'm referencing gRPC and gRPC tools. And gRPC tools is the one that's providing a bit of magic here. It integrates, this is Google's bits, they integrate into the build pipeline. So that when I have a couple of files here, these are .proto files, and when I hit build, because I've got that gRPC tools thing in the project, it's going to sneak into the build pipeline and just do all the magic. So you can see here that you can kind of get a feel for what I'm defining. I'm saying that I have, as part of my contract, my service that I want to exchange with people, I've got a couple of different messages. So these will be very familiar if you've ever worked with XSD or anything like that, but obviously simpler. So I've got, obviously multiplying two integers together is a really, really complex thing, and that's not something you can do locally. So what you need to do is you need to use a complicated RPC framework, send it off to the cloud, where you've probably got a machine learning supercluster with GPUs or something to do that work. I'm guessing it's a pretty simple matrix for doing that, and get the result back. So, you know, obviously it's not a real world scenario, but it's something nice and simple that people can understand to kind of get a feel for what it is. So I want to have a service that multiplies two numbers together and gets a reply back. So yes, I can come down here and I can define that I have a service that is a calculator, and as part of that, I can have any number of methods. So I could also come in and put in another RPC method here. With some kind of, I'm not going to do it, but you know, I could add more methods there. It's not one service, one method, and I can define that service takes something and returns something. It's always one something, and it always returns one something-ish, which I'll come on to. But the key point there is I can't parameterize this and have kind of 6 parameters. That's not the way it works. What you're really doing here is declaring what the payload shape is that I should expect. That doesn't mean you can't send multiple things. It just means that, say for example, my multiply request, I needed to do like some kind of complicated auditing, and I could define in here a message user string name equals 1. And as part of my multiply request, I could have a user. And you'll notice here, so I've kind of this is just defining fields, very, very familiar. The little integers on the right are how Protobuf actually recognizing things. It never sends the names across the wire. It just sends the integer. So it's really, really important that you don't mess around with the numbers. But you can actually change the names if you really want. I'm not saying it's a good idea, but if you really wanted to, you could change that at a later date. And as long as you're using the binary format, not the JSON format, nobody would care, nobody would notice. It would all just deserialize fine, because it would still be field 1 goes into there, job done. Right, so you can see there I'm kind of defining a request and a response. And I've even got just going to make sure this is nice and non-ambiguous. Yeah. So the question is, would I need a separate message kind for a different service? The answer is no. I can reuse message kinds between services if that makes sense for the service. A lot of times you're probably going to have a the outer payload is often going to be very kind of method specific, but it might have things inside it that are kind of shared between multiple services. In fact, I should also stress you're not just limited to having one of anything. I can also do repeated. So that's essentially just the same as list of. In fact, let's just do that. So hopefully, I've just hit build. It's going to think for a second. And so on the right here, you can't see the font, but just trust me, there's a couple of solutions there. You don't have to do it this way, but the way I've got it working just for this demo is that I've got one project that's got all the contracts in it, but doesn't reference anything to do with services. And then I've got two other projects, one the client and one the server, and they just have a project reference to that one, so that's how they're getting the contracts. So, but there's other ways you could do that. I could have just dropped the .proto file in both of them, and that would have worked fine too. This is just for a way of doing it. So I've got this demo here, but I have not defined anywhere, I've not actually written a class that is a multiply request. So if I go into the client, it may be interesting to find out that these things do exist. So that does not, there's my multiply request, I'm using it down there, and it does not have any red squigglies. So how did that work? So if I F12 into it, you won't be able to see the file location, but it's somewhere under the obj folder. So basically it spat this file, generated this file as part of the build pipe. It does exist, it's just not part of our source tree, and you wouldn't normally commit it to GitHub, but it'll just work automatically. And as you can see, it's quite verbose for something that's just 485 lines for something that's just kind of defining a couple of contract types. Now, some people think that's fine, I don't need to know about it, that's just generated code, I don't care. And some people think, God, that's kind of weird. Both options are fine. We can work with this. I'll show you. We're going to look more. But if you remember, we had a look at our multiply request, and we had in there our. Let me just look at one of them. So we've got a multiply. In fact, this might not be the right window to look at it. That's going to be really, really confusing. Let's just look up here. Var obj equals new multiply request. And what do we get if I do that? I get an X and a Y. So I can do those. And this is the one I added. And it was a list. So it doesn't look like it from the naming, but it is actually a list. So if I use list collection semantics, so there you go. You can see there that this object fully exists, and it's kind of like what our DSL suggested. It just works, which is kind of better than the alternative, really. So what are we going to do? We're going to set up a gRPC communication. And so this works over HTTP2, so I need an HTTP address. So this is going to just be a standard URI, basically. And all we really need to tell it is the server name. I'm just going to use localhost, talking back to myself, and the port. I've arbitrarily chosen 10,042, nothing special in that, other than an excuse to get 42 into any random place. And I'm going to use insecure here. You would not normally do that. Please don't use that as an example. Only reason I'm doing that is because you're watching me mess around with certificates for 2 hours. Probably isn't the best use of your time. Just take it as read that gRPC assumes has all the things you would need in terms of TLS and all those other things. They're just built in. I'm just not going to show them. What would I need to do then, from a client perspective? I know I've got this service, I've got the proto, it's all worked. So basically, Google in the gRPC thing in the gRPC library define this thing called a channel, which I can new up, and I can't remember whether it's disposable or not. It doesn't matter. You can just shut it down. And once I've got a channel, I can then create clients. So what the code does in that generated mess that we had before, for every service, it generates some server stubs and some client stubs. And because we're looking at the client here, the calculator client takes a channel, so that's how you're going to talk to the thing. And then once we've got that, we can just use it basically like you would an interface or an abstract type. It's just, it has a multiply async method because I defined a multiply method that takes a multiply request. I await the response, and then it gives me the result. There's a couple of oddities here in the API, just in terms of how you actually need to access things like the headers, which is why it isn't quite as simple as just a standard async await, just because of where those things are located. But it's all pretty doable, all pretty usable. So that's the client, nice and simple. And so let's have a look at the server, because obviously we need to, this is for our GPU supercluster. And it's not hugely dissimilar. So what I need to do to implement a server is I need to subclass the thing that's actually in the generated code. So obviously when I'm using a client, I don't need to generate anything, the tool's going to deal with that. For the server, we need to actually tell it how to do the thing, how to do the multiplication. So that's why I need to subclass. So I get a base class for every service that I've defined, and all I need to do is override each of the methods that I wish to implement. And then you won't be surprised to find that it gives me a multiply request and some bits that contain things, a way of accessing things like headers and other information. Then I can get information about, who's calling if I want to, do the actual multiplication, and then finally return the result. Notice here that it's doing, in this case I'm using task.from result. That's because this is an async API, it assumes that most of the time you're probably going to have something more interesting to do, and that's just a simple way of kind of making something synchronous look asynchronous, which is very different to sync over async or async over sync, which you shouldn't do. This is just wrapping it up for the API. But there you go, that's me implementing the actual service. So we need to actually hook that up to the Google bits. So all we need to do is I'm going to new up my server there. Don't worry about the clock, that's just another example. And then I'm going to tell the server object here is the kind of the Google thing that's really doing all the work of kind of listening to actual sockets. And all I need to do is tell it the location, again, localhost 10,042, insecure, and I just tell it to bind service to my calculator, which is the thing I newed up here, the thing that actually got code in, and then just start the server. So let's see if that actually works. This is where I really need that new terminal thing. So I come into GRPC in each of these. .NET run. Hopefully, we'll get the world's most complicated calculator. There we go. So all I've done is multiply some numbers together, and there's also some other things there, kind of showing some other APIs. So that's kind of the most simple usage that you could possibly imagine of kind of gRPC. But there's a lot of, that so far you might, I would happily forgive you for not feeling wowed so far. That this is okay. There's a lot of code there to do, not a lot, although maybe it'll work. So what other things can gRPC do to make things easy? Those are quite solvable problems. Yes, you've got things to do with the efficient transport, but overall it's not doing anything particularly exciting so far. So let's look at some other things that we kind of have available to us. One of those things is the idea of streaming. So I kind of looked at some of this already in the clock demo. So the idea, what is a stream? So a stream is basically a discontinuous sequence of things happening at either end, which is very vague. It's basically an open channel that at any point, rather than just sending one message, I can send any number of messages as they become relevant. So obvious applications for this might be, for example, a chat application. You could have, and I could be sending messages to the server as a stream. So every time I actually type a message and send it to the server, I can drop it into the queue. But also I can be listening to those messages as a stream. So I'm not having to keep polling the server. I can just have an open stream of messages, and all I need to do is ask the code, can I have the next one please? Can I have the next one please? And when they actually send something, it can come back to me. So other applications for that obviously might be trading systems where you might have a stream, but it's basically anything where you've kind of got a stream of data, Twitter or anything like that. It's just a stream of data. Don't confuse it with I want to send multiple of something, a list of T. If you're doing that, you would just use a single message with repeated of something in it. This is for sending usually things that are separated by time. And in fact, you can have full duplex. So you can have, I can send one message and get multiple things back, or I can send multiple things and get one thing back, or I can have two completely unrelated streams, one in one direction and one in the other direction. So it's a full kind of bidirectional streaming. It's quite complicated to get your head around, but you can do that. And that's not something that's very easy to set up. So that's one of the things that makes it very tempting. So let's have a look at how we might do that. So like I mentioned, the clock is an example of that. And all I'm doing in here is saying I'm going to subscribe on this clock and send it an empty message because, what do you tell the speaking clock? Just say, I'm interested. Unfortunately, like I said, you always have to send a message. So there's a kind of a well-known type called empty. You can just say, I'm sending nothing. Now give me a stream of things back. And all I'm doing is doing a while await move next there, which that would be familiar to anyone who's looked at the C#8 async enumerables. That's kind of a very obvious async for await for each, but await for each needs some APIs that have only became released yesterday. So this will probably move to await for each soon. But if not, it's pretty easy to see what's going on there. It's just a while loop. While there's data, get me the next one. So what does that look like at the server? So I've also got my clock service, and all I'm going to do is I'm going to loop, and 5 times in a row, I'm going to send a message to the result, to the output stream, and then I'm going to wait 5 seconds. In fact, no, let's just change that because demos, 5 seconds is a hell of a long time on a screen. So that's kind of what this other part, the demo here is showing, is setting up streaming. And obviously, normally it wouldn't just be a fixed time. You'd be kind of doing things based on some kind of queuing system or however you're doing your messaging between systems. So if I get the server going, and get the client running. So there you go. You can see there the server's now dropping a message in the queue 5 times, exactly what we told it to do, and the client didn't have to do anything interesting, and the server didn't have to do anything interesting. We just got all of that for free, all the usual async await goodness. So our CPU meant to do more interesting things while there wasn't anything to do, and the library deals with all the threading model for us. So that's cool. Another interesting thing we can do is cancellations, which is a very interesting concept. So normally, you've sent a message to the server, now, and that's probably going on to do 16 other things, including talking to databases or other platforms. And then your user over here times out or clicks cancel. And right now, that's a real pain if you want to kind of propagate that. So GRPC actually includes cancellation support via an out-of-band mechanism. So rather than having to deal with your own kind of cancellation API, you can actually use GRPC for all of that. So if I look at the server here, I can actually, let's do something, blah, blah, blah. I get a cancellation token on the service, and I can do whatever I want to do. Maybe I'm just going to throw if cancellation is requested on the cancellation token. So he's going to loop 5 times, and that's, in fact, let's make it 50. But what I can do at the client now, very, very easily, cancel new. What is it? What's the name of the type of task cancellations? I've forgotten it. Cancellation token source, is that him? Yeah. So I can create a cancel thing there. And now what I'm going to do is I'm just going to cancel after the first one. Cancel. Now that's, and of course we will actually send it in. That would be a nice idea. So as part of my call options, I can send it I can send a cancellation token to the server here, just as part of our options, and then at any random time I can cancel it. Now that's not cancelling at the client, so that I'm not telling it to break out this loop. I'm just cancelling a token that's got nothing to do with that loop whatsoever. I'm not throwing in that loop. But now what we should find, if I run the server again, it didn't work. Okay, I'm not going to try and debug that now. Never change code in demos. In fact, it's doing very odd things. Okay, that's interesting. I'll have to look at that later. But I should have propagated correctly. I've broken the world. Oh well, that's okay. We can live with it. But the idea is, it's a hand up.
Yeah, just thinking about cancellation, thinking about errors related to that. Is it resilient to things like network dropouts, or do you still have to code around?
So in terms of network dropouts, what we're talking about here is a single HTTP request, multi-frame HTTP request. So it doesn't have automatic kind of retry and things like built in. You would have to build that around that, although I think there are some mechanisms that kind of add that kind of layer. But no, automatic retry isn't built in. So it's not designed for, it's designed to actually do the RPC bits, not the resilience bits. Right, anyway, those kind of the key points. So let's just jump back to my slides a sec. Blah, blah, blah. All right, blah, blah, blah. So things we should have seen, got the basic project set up, a .proto schema, generated code existed. It isn't very fun to look at, but it exists. We looked at how to implement and host a service, and we looked at how to create a client. And we should have had a kind of working client and server. One thing I didn't look at there was how to get rid of hold of metadata, but on that extra parameter on the server and on the call app options that I passed into the client when I passed in the cancellation token, you've got the access to familiar APIs that you would use to get hold of HTTP headers or to send HTTP headers. Although in HTTP2 and GRPC, there's also something called HTTP footers, which is exactly what they sound like. They're headers that come after the data. It's useful sometimes, I guess. But like I say, all you need to do is those are all available on the API surface. And cancellations, I'm going to have to keep this code and have a look at what went weird in there. But in theory, cancellations work, and that should allow you to kind of propagate that data down. So you could take the server, for example, you could take that cancellation token and pass it into, I don't know, Dapper or something, or however you're doing your database access, just as you're kind of breaking out of things, with as little overhead on the server as possible when somebody's clicked cancel. Security, yeah, we're not doing those things, but they exist. So, what have we got? Just to summarize, we've got the generated code, and that all sits on top of a library called GRPC Core .api. And underneath that is GRPC Core, and this is kind of what gets relevant for the .NET Core 3 bits. because at the bottom there, at the moment, all of that was based on CHTP2. So even though we're in .NET land here, under the bonnet, we're basically bundling up a big C or C++ DLL and shipping that out to the client. In fact, if I go into my output directory, you have to see it as a big old chunk of. I think it actually combines all the CDLLs into one blob so that you can't see them, but they're there. So what's the strengths and weaknesses? So by having this DSL, we get a strong platform for talking between different platforms. So you can here I've generated code for .NET, but not everyone deals in .NET. So people in sort of Go and Java, and you can kind of see here that that same .proto file could now be shared between lots of people of all kind of different platforms and technologies and languages, and that would kind of work. So that's a good thing. It is a bit of an overhead. It really depends on whether that's a useful thing for you. Kind of depends on what you're doing and kind of who your teams are. Obviously, if you're working between companies, that's probably a kind of a good level of overhead. If you're just working between, system A and system B, and you write both of them, that might not be such a useful thing. The tooling can be a little bit awkward to set up. There's a reason I didn't kind of start from a blank new project, because sometimes you need to kind of remember whether to swing the cat clockwise or anti-clockwise to get it all working. But in principle it works. But I guess for me one of the big things is what Google give you is idiomatic gRPC, and it happens to be in .NET. Now that's fine if you are, say, a multi-platform developer and you do a lot of gRPC, because you're probably going to want a nice, consistent, familiar API between all those platforms. But if you're mostly interested in .NET and the fact that you're using gRPC is an implementation detail, then you might find that a little more awkward. My kind of preferred way of things is just I'll have a idiomatic .NET, and it just happens to be dealing in that. There's a reason why XML serializer and JSON.NET have a very similar API. It's just object in, string out or whatever. So that's kind of the whole kind of idiomatic .NET kind of side of things. And so for my money, I'd prefer to have an RPC stack that's kind of a bit more .NET centric rather than gRPC centric. So that's fine. We'll get there. And a really, really important point. Right now, so we're only looking at the Google tools before the quick break, which will be in a couple of minutes. But the code gen is C# only if you're in .NET land. So that tooling, it'll only spit out C#. And there's actually two subformats of the DSL. So there's Proto 2 and Proto 3, and they're not supersets or subsets. They're kind of, there's a Venn diagram of kind of things. So if you're working with somebody and they've got a Proto 2 schema, tough. Actually, no, tell a lie. I was talking to John Skeet back in Reading last time I gave this talk, and he said they may actually, there's a chance that may be on the way to actually handle the Proto 2. And like I said, at the moment, it's all sat on top of this native unmanaged layer. So it's not going to play nicely if you're in kind of Kestrel and you want to reuse whatever your Kestrel is working on, and it's not going to make use of those other nice things. And you get this great big chunk of verbose generated code. Whether you care about that, that's up to you. And there's that weird for each loop thing. But that's kind of what gRPC can give you today using just the Google bits. And as you know, that would have been true up to yesterday. On Monday, this is... so I think that's probably a good time to break. And then I'll let Dan own how long that break is. And then after the break, we'll look at what all the new and interesting things that are coming up in .NET Core 3 and why this is suddenly gets a bit more interesting yesterday.
Does that mean the exception just got sent back to the client?
The client responded with an exception. I don't know. I have to look at. I'm not going to. I don't want to. Yeah, I don't want to get down into that rabbit hole now. The cancellation kind of worked. Well, I can look at it later. Right, so before the break, we looked at how all this stuff works with the Google libraries that have been available since whatever year, 2015, it said. Now, a lot of things are changing. So what can we do with .NET Core 3? What's kind of new? So the big news, well, not so much news, but it's not a surprise to anyone, is that Microsoft have been writing a new set of libraries that work with the existing generated code. So everything that I've kind of shown so far today, it's not that they've gone away and reinvented a whole new playpen over here that you need to do things the Microsoft way. No, they've been really good. They've worked with Microsoft, and they've I think they even helped partition the libraries into the right layers for this. But they've got a whole new set of libraries that allow you to work with your existing code, but using managed endpoints. So you remember previously we had CHTTP2 sat at the bottom as a big ugly thumb, if you like the managed world. Microsoft obviously kind of agreed and done something about it. So what does that mean? So there's new client bindings that under the hood they make use of the new HTTP client technology. Although you don't actually need to use HTTP client yourself anymore. You did at one point in the RCs. Now that's all hidden away from you. And there's new server bindings that, unsurprisingly, are now based on the Kestrel server. So that's the ASP.NET Core server, which is a very, very good server. It's the one on the second power benchmarks that's just rocking it. It's a very, very high throughput, highly efficient server technology. So it's really not to be sniffed at. It's a kind of good bit of kit. So what does that mean? So we had this slide earlier where we had our ugly duckling at the bottom, CHTTP2, and that was all coming in from GRPC Core, which is basically the wrapper. Really, it would be kind of clearer naming if that was gRPC native or gRPC unmanaged. That's kind of what that really means, that .core there. So Microsoft are adding, or have added now, a gRPC.NET Client that sits on top of HTTP client here. So that's for when you're doing your client side bits. And they've also added gRPC ASP.NET Core server, which sits on ASP.NET Core. So what that means is if you don't want to use these bits in the middle here underneath the gRPC Core API, you don't need to anymore. You don't even need to ship them. You don't reference them at all. Just go away from your project and everything keeps working. So let's actually do that. As I said, so let me come back to my project, close all documents. Now on the right here, I've got lots more demos. And one of the ones I've got is blah, 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 .NET gRPC. So this is using the exact same ideas, but using the new Microsoft bits. So if I just have a look at one of these packages, the CS Proj, very, very simple CS Proj. I'm not adding anything except for GRPC Net Client there, which is this is the client library, so I need the client bits. And I'm taking a reference on that same shared project. So that's just referencing the core API layer, not the core layer that's got all the unmanaged bits in it. And the reason I'm referencing the same library is because nothing changes. The exact same code that you had today works. That's kind of the entire point of this. So let's have a look at what we need to do to write a client in the new world. The first thing that I need to explain is this first line. That's just because normally HTTP client really doesn't want to talk HTTP2 without TLS, and I just need to kind of take it by the hands a bit and shake it hard. Say, please, I know I'm being an idiot. That's okay. It's only for this. Again, you wouldn't need that line because you're going to be using TLS and certificates, and it'll all be good. So all we need to do then is you'll notice this gRPC channel type here. And if I F5 into that, you'll see that it's coming from gRPC Net Client. So that means this is the new Microsoft library. And it's got some APIs here for creating a channel. And that works very, very similarly to the channel that we had in the GRPC code, the unmanaged code. Obviously, it's just a different type and a different namespace to tell the system what we're trying to do. And I just give it my endpoint. I give it a URI here instead of specifying the address and the port separately, but I think we can understand what it's doing. And then all of the other code stays the same. It's pretty much exactly the same code I had before. There's nothing fundamentally different in there. All the APIs I had previously are still there. In fact, these are exactly the same types. This is exactly the same calculator client that we had before. Nothing has changed. This isn't a whole, this isn't a parallel world of Microsoft bits. This is the exact same code. I just can't emphasize that enough. So the client, very little change. Really, really simple. In fact, what we can do, hopefully, is to prove this. So we've got our server here that's still running the old version, and we can go back a layer and go into .NET GRPC and we should, there we go, we can run our new client here. So this side is on the Microsoft stack and this side is on the Google stack, and they can still talk to each other, and you would hope that. I mean, ultimately, if you're going to be able to talk from Java on one and Go on the other, you would hope you'd be able to talk from .NET to .NET that just happen to be using different underlying implementations. So there you go. So that worked. Everything's happy. Things get a little bit more complicated on the server. So let's just have a look at the server. Again, the CS proj is very, very simple. It's just a NetCore App 3 application. I do need to emphasize the new bits that Microsoft is shipping here are tied into NetCore 3. So there are changes, fundamental changes in the HTTP client implementation and in Kestrel itself. So this won't work on Net Standard 2 that just happens to be shipping in the NetCore 3 timescale. It needs NetCore 3. Okay, so we've got a NetCore App 3 project there, and I'm taking a package reference on GRPC as NetCore Server, and at the top here, I'm also taking an SDK reference on ASP.NET. Basically, this is roughly what you'd get if you just did a file new ASP.NET Core 3 in your solution. So you got a new Kestrel project, and then you just added a reference to this library here. So that's what we've got there. But we do need to make a few more changes in this side. Again, I think there is a template that will set up a lot of these things for you. But if you're not dealing with a template, then what are those changes? So this is pretty much boilerplate Kestrel. If you're not familiar with it, I'm not going to try and explain Kestrel in this thing, but it's a very kind of you can configure it through code rather than config files. So this is the kind of configuration. This is the configuration, and we've made a couple of changes here. In particular, when we're creating the host builder, we need to tell it that we want to use the web host rather than, I think it's the HTTP host was the old one. I can't remember. And the reason we need to do that is so that we can tell it here that we want to listen on HTTP 2, because obviously gRPC is tied to HTTP 2, and it won't work if your server is only expecting HTTP 1.1. That's just not going to work. Excuse me. So that's all I'm really doing in this file, which again is just some minor tweaks. The other part is in the startup file. You normally get a couple of a method where you can kind of configure your services, and there's a line you need to add here. This line I'm on, just services.addGRPC, and that's an extension method that's added by the library that we taken a dependency on. So if I go into that, there you go. It's coming from GRPC ASP.NET Core Server, and it's just going to do all the things to kind of configure gRPC so that we don't need to know about it. And then finally, we tell it to map our services. Now there's a slight change here. If you remember on the Google one, we created an instance of our service and we said bind service. So we were kind of in control of the kind of the object life cycle there, the lifetime. That's not the case in Kestrel. Kestrel takes control of the object lifetime. So all I'm doing here is telling it the type of service that I want, and then Kestrel will worry about actually instantiating the server object when it needs it. One of the interesting things about that is you can also use all of the usual Kestrel IOC DI tools. So if, for example, my calculator object here, if I added a constructor on that took an iLogger of my calculator and whatever other services that I wanted, then as long as I told Kestrel how to resolve those services, again in this configuration, it will worry about getting the type constructed in the way that it expects. And I think you could probably also configure these as singletons and all the other things you can do in Kestrel. They just work. Other than that, my calculator is still exactly the same thing. Obviously, like I said, all the code we had before just continues to work. So just because we're changing the server implementation doesn't mean I need to actually rewrite my services. So my service still exists as a multi-line method that subclasses calculator base, does all of the exact same things that it did before. I don't think there's any kind of other major changes in there. In fact, that's just for the fun of it. Let's public. So I think this is the right logger. So just to prove that all works, thank you. You're right, absolutely right. So generate, just give me a field. How is that hard? Private, read only that. So I've got a constructor there that populates a field, and now hopefully if I can just do, let's log a warning. So what we should do is, we should see that happen. So let's come out of here, and out of here. Fine, am I still on the mic? No. Right, so. I should note the Kestrel server, just because of the way it's implemented, by default it's quite verbose in the logging. You can kind of configure all the logging, but it's by default it tends to just be it's quite shouty. So don't be shocked at the amount of blumph. So if I .NET run that one, there we go. So it's discovered all the things here. It's added the methods, and it's now listening on that port. So what we should now be able to do is run our client again, and the client doesn't know or care which one it's listening to. I think it can sniff the endpoint and can actually get hold of that. I think the Kestrel one happens to send an HTTP header that identifies it, but normally you shouldn't actually care who the server is. But you can see there, it did work. Did we get a warning? Yes, we got an eek at the top there. So that was our constructor injection happened. So you could replace that with or add any other services that your software needs to actually do whatever it wants. I'm not going to offer any guidance on the rights and wrongs of service injection, but it's a thing, you can use it. But it worked, and as you can see, there's an awful lot of code under the bonnet there by Microsoft and things, but from the perspective of a consuming developer, that just worked, and now we don't have to ship any of those unmanaged binaries, so that's kind of really quite tempting, especially kind of targeting multiple platforms. It'll just work as long as we can target .NET Core 3. Although I wonder whether needing to target .NET Core 3 is actually more restrictive than the unmanaged binaries, but it's sound in principle. Anyway, so that really, in a nutshell, is kind of what Microsoft have been working on, and kind of what's the new bits that they've got to show there. So as I said, I'm just going to configure our services, map them at the bottom there, and exactly the same code, and it just works. So we can see we've created a server in Kestrel, we created the client in HTTP client, and everything was the same. Now we've still got all the other pain points. Now I was having some conversations in the break, and there's always this big divide between kind of the code first and contract first developers. Now Google, for very good reasons with kind of gRPC and Protobuf, are kind of very strongly in the kind of the contract first side of things, which means you need to define your things in this DSL that says these are my types and these are my services, and that then makes it really easy to export that into a range of different platforms. But it has some overheads if you're kind of doing some very, very simple things. And like I said, that tooling, it's good now. It's actually better than it ever has been. Back when I kind of started with all of the Protobuf and gRPC things, it was actually a huge amount of work to actually get the tooling working, and it didn't integrate into the build pipe, and it didn't integrate into the IDE. So you'd have to have a separate step in your build to go away and take this DSL and generate the code files. A lot of that pain is gone now, so most of the time you've just got these .proto files and things work. It's not entirely painless, but it's better than it ever has been. So kind of what we've got here, we've got a proto schema that emits some generated code that happens to reference Google Protobuf for all the serialization bits, and we reference this library that I mentioned earlier that now Microsoft and Google can consume separately. So there's deliberately a big chunk missing on the right-hand side there. It's not an accident. So the other thing I want to kind of show you all today is another set of tools that are kind of interesting. I say this slide is badly titled. The things I'm going to show you now, they're not actually specific to .NET Core 3, other than they were kind of timed for the release of .NET Core 3. And the reason for that actually comes down to the iasync enumerable of T interface, which is the new interface that allows you to kind of describe async streams nice and easily, and that ties into the async for each, the await for each syntax. So that was only officially released yesterday. But the good news is Microsoft have been so kind as to define backport that interface into a library that you can now consume on down-level platforms, which means that and there's all the usual type forwarding in there, so that if you target it on one platform and then update your platform later, everything will resolve correctly, and you'll get the ones from .NET Core 3 if you're in .NET Core 3. Otherwise, you'll get the ones from the bait and switch approach they use. We'll see why that's important in a second. So what I'm going to look at now is some new tooling. So this is based on the Protobuf-net stuff that I work on. It's not the Microsoft stuff or the Google stuff. And it's Protobuf-net gRPC. Now as I mentioned in the very, very first slide, I'm very, very much into kind of metaprogramming and kind of code first. It tends to work well just because a lot of the systems I work on, they tend to be teams working very closely together, not kind of different companies or working in different languages. I'm mostly .NET, so for me, kind of code first works quite well. And the good thing is, the tools that I like to show, they work against either the old unmanaged Google bindings or the new Microsoft bindings for both client and server. So again, we can just take our choice. So if you're working, I was talking to somebody else in the break who's interested in these things, but they're going to be looking at kind of IoT devices, but not trivial IoT devices, proper IoT devices. The .NET Core 3 isn't an option, but you could still use the tools I'm about to show you, just that you'd be using the CHTTP2 bits in the middle, not the Microsoft bits. So we can have lots of options available to us. Again, Because this is kind of built on top of the Protobuf-net code, it defaults to assuming you're going to want to use Protobuf-net. But if you want to use something else, you can configure it. And I'll show you what Protobuf-net is in a second, in case you haven't seen it before. But what it really does, the kind of key point of it, is that it takes all that API surface that we've just looked at, that kind of the Google shape, and it just refactors it. It puts it more kind of a cleaner API. Supports code first, but it can also support contract first. All we need is a generator to take your DSL and spit out the contract, and Protobuf-net has a generator that does that, although that bit hasn't released yet, just because I'm still working with somebody to get the website updated. So we don't lose the code, the contract first side of things. We still have that. We have the choice of both. And so I remember one of the pain points I mentioned earlier. Right now, if you're dealing with the Google code, you can only use Proto 3 for the C# generator, whereas Protobuf-net's parser, because it's a completely ground up, starts from nothing, doesn't use any of the Google's bits. It can talk Proto 2 or Proto 3. In fact, we recently changed the API to split out the complex bits and the simple bits, and we actually have this now running in the code generator running in Blazor on the client side. So you don't even need to have anything set up. You can just or send anything to us. You just go to the website that isn't released yet, but it's on GitHub, and you can do all the code gen side in Blazor if you like. Or there's the exact same tools that you saw for the Google bits in terms of the build pipe. Those tools again exist for Protobuf-net, so you can just drop it in your project. It'll generate the things at runtime. When you hit build, it'll just work. But more importantly, it isn't limited to C#. I mean that in two different ways. The first way I mean it is, if you're dealing in code first, then that probably means you're looking at reflection APIs. When you're dealing with reflection, it really doesn't matter what language something was written in, as long as it looks like a .NET-y object with kind of the right kind of shape. As long as whatever tool, your metaprogramming tool, understands the shape of something, it won't even care whether that was VB or C# or anything else. Just work. But also the generator actually does include some other language. It includes VB. If somebody wants to volunteer others, I'll happily take them. I know just about enough VB to read it, so getting it to even work was fun. But if anybody's really interested in other languages, hit me up. Does anyone remember WCF? So a lot of the things I've kind of been describing so far will be very, very familiar to anybody who's worked with WCF. So for those who haven't, in WCF, this was .NET 3.5. It was .NET 3, not .NET Core 3, .NET 3. And basically, it was one of I think 5 different technologies that shipped in that stack. And it was the RPC stack from Microsoft. It had lots and lots of complicated bits that very few people used. But at the heart of it, what it allowed you to do was define contracts as interfaces and define the things you were sending as classes. And okay, you might generate those from a MEX file, which is kind of like WSDL. But in general, you'd have been working code first. So I'm only talking about the good bits, not all the really, really complicated bits. There's no net data contract serializer or whatever. So if we go back to this slide, what about if we plugged in a whole new chunk over on the right here that allowed us to, rather than using contract first, we could use code first. So instead of having our proto schema to define our types, we just have our types to define our types. And rather than having a whole bunch of generated code, we let the metaprogramming layer deal with that at runtime. It can just have a look at this thing and say, hey, I know what to do with that. Just make it happen. And instead of having to reference Google Protobuf, we can reference a whole range of other serialization technologies to make all these bits work, and still have everything work through GRPC Core API and either the Google bits or the Microsoft bits. that kind of spat out under there. So how might we do such a thing? This is where we go back to code. So I've got yet more examples here. Blah, blah, blah. What I have, no, don't give too much away, is a yet another client and server, and you will not be amazed to hear that it's yet another calculator client and server. Sorry, they're not very interesting or challenging examples. That's kind of the point. They're kind of to prove what we're doing, not do anything intelligent. So remember previously we had that DSL that defined everything. What we're going to do now is instead, you can kind of see how that DSL is basically defining what we might think of as an interface in .NET terms. So why don't we just do that? Let's have an interface that is iCalculator. And let's have on that a method called multiply async, just to follow the .NET conventions, that takes a multiply request and returns a multiply result. And what are those things? Well, they are classes. So we've got a multiply request here that has an X and a Y. And here, in this example, just to prove that I'm not taking any magic here, I'm actually using the data contract serializer attributes here to help annotate it. So this is where, I remember previously we had to say X equals 1 and Y equals 2 in the DSL. The library still needs a way to actually understand which field is which reliably. I've seen lots of people try and suggest ways of doing it that just kind of works magically without having to add kind of attributes, and they're all terrible, terrible ideas. The typical one is, well, let's just order them alphabetically. That's fine until somebody goes and adds a aardvark count or something, and everything shifts down by 1. And all of a sudden, the data you were serializing before doesn't work. So the exact same rules that we had in the DSL apply here. We do not want to change what numbers mean what. So it's a really, really good idea to be very, very formal and say X is 1, Y is 2. Very, very simple, but effective. And we'll do exactly the same thing here with multiply result. And value task here is obviously just the standard async APIs. Although this would actually work just as well if I made that task of t, or if I just made it return multiply result, then it would do it synchronously. It'll just do what you expect. It'll just work. So there's our client. Now, how could we consume such a client? Let's have a look. Here, we have a client that's using that library. And just have a look at the project file. Again, I'm going to take a reference on GRPC Net Client. That's just because I'm using the Microsoft's implementation of a network stack. I could also be using Google's implementation. It wouldn't matter for the purposes of this code. It'll work with either. And I'm also going to take a reference to Protobuf-net GRPC. There's some complications in there just because this project's set up to work in stable or experimental modes. Don't worry about those bits. So that line, remember this line before and the other one? There's just a little bit of code there that just makes that a little bit cleaner. So GRPC Client Factory is the class that's coming from the new library. But this line, the for address, is exactly what we had before. That's basically the Microsoft bit saying, give me a channel to the server. I'll tell you what to do on it in a second. So now, all we need to do is get a calculator. So that's this line saying, on that channel, create me a GRPC service of type iCalculator. And the runtime will go away and say, have I seen this type before? No. OK, let's have a look at it, inspect it. Or it'll just, obviously it caches that, so it doesn't have to do that work each time. But it's going to have a look at that interface, and it's going to understand what the methods are on there, and it's going to understand all the usual patterns for gRPC in terms of how to map that to what the other libraries are expecting. So once we've got a calculator, we can just call a method, and you won't be surprised to see that because it was a value task of result, all we need to do is await it. And we get exactly the same things that we had before. I'm also going to, actually no, let's have a look at the server as well while we're here. So here I've got the very similar code based on the Kestrel server. So once again, we've got the complicated program and startup, all the usual Kestrel bits. But we need to tell it about our service. So what am I doing this time? I'm going to tell it, instead of add GRPC, I'm going to tell it to add code first GRPC, which is the extension method. Not much different to the code we had before. And this bit is exactly the same. Thinking, hang on, how can that be the case? This made no sense. We don't have the my calculator anymore. So all we're doing now, my calculator just implements that interface that we defined, exactly the same as you would, say, in WCF. And all I'm doing, exactly the same as before, I'm just saying that the implementation of multiply async is this. And it would work with regular implementations or explicit implementations. It'll just work. And there you go. So there's us doing our complicated math and returning the result, in this case as a value task. So what would that should actually now work. Let's go give that a try. Blah, blah, blah. So that's Protobuf-net GRPC, client C#. Oh, it's server, isn't it, this side? Let's keep things consistent. .NET run. And on the other side, it doesn't sound good. CD pbnet grpc client C# .NET run. And hopefully we should see, there we go, things are happening, exactly the same as before. So that's cool. It's a slightly different example, so the time code isn't in here at the moment. Oh no, there it is. It's obviously on the 5-second delay. So that was just a unary thing where I'm sending one message and getting one message back. So the more interesting thing for me is how this changes when we talk about streaming. So I've mentioned the iasync enumerable API before a few times. So we can look at that on the clock service here. So before this was in the Google code, it's actually quite a complicated API to kind of express what a stream of things look like. Well, that's now really well defined by Microsoft. It's an iasync enumerable of t. So all we were going to do is have a service that has as either the return value or the input parameter an iasync enumerable of t. And then our code will know what to do with that. So how can we actually consume that? Well, actually, no, let's look at the server first. So from the server, C#8 has support now for writing async enumerable methods, exactly the same as you would iterator blocks in C# before that. So you just do a yield return, but you're now allowed to have awaits in the middle of them. So that's nice. So all I'm going to do is await in the middle. So it's going to pause. That state machine is going to go somewhere, and then it's going to reawaken. All the usual async await magic happens. So our CPU can go and do other things. That's not just going to sit there blocking. That's not thread.sleep. And in the client, we get the new syntax. This again is C#8. This is basically a for each loop. But if we add the keyword await before the for each, then it becomes an asynchronous for each loop. And again, all the things that you expect to happen, it just works. The library deals with all the heavy lifting in there for you. So if I .NET run that again, in fact, no, you can see them on the screen there. Every 5 seconds, that one's going to wake up, send a response to this one's going to wake up, and thus the cycle continues. And you can do that in either direction, client to server, server to client, both. It's all good. So that's kind of the main things that are there. Now, one of these windows, let's jump back to the slides for a second. You also notice in there that I in the service contract, I defined a name at the top. That's really just to make sure that it binds correctly to exactly the same URI in terms of the bits after the slash that the original server was working. So that just makes sure that we can use any of these servers with any of the clients. So there's the steps we ran through. But the interesting thing for me is, again, if we come back to the code, so here I've done some code for C#, but the library doesn't care what language you're in. So if you're not a C# developer, maybe you're a VB developer, so we can do exactly the same thing in VB, and you can define your contracts as you would. Just change the squigglies to anglies, and it'll all just work. Again, you can set up, Kestrel works perfectly fine on VB, even though I don't think there's a template for it. It works just fine. It doesn't care what language it's in. But you can even do it in F#. So I've got the exact same demo here. If you want to come in and define the exact same types in F#, that's how you would do them. There's usually about 18 different ways of defining things in F#. But that's one way you could do them. And you can set up a Kestrel server and a client, again, in F#. So I think bang here is the same as await, for example. So you can see here that no matter what technology set you're kind of using as a company, you now have options to kind of exploit these tools natively. You could probably do a lot of the same things just by going through the Google hoops and compiling that into a package, a nupkug that you then consume from your F#. But if you want to do everything clean and in one place and in one technology stack, this kind of gives you kind of those options. So jump back into here. So things we've seen. We've kind of defined our data and our services as simple classes and interfaces. We've got a server. It'll work with GRPC Core. I didn't show it, but trust me, it will. We showed it on Kestrel and HTTP client. It doesn't matter. Again, I didn't show it, but the tools, the Protobuf-net tools, can generate. In fact, no. Let's do that. That's interesting to me. Blah blah blah. So again, I've got the same kind of DSL kind of that we had before. It's a bit simpler now. I haven't got the clock one. So if I go into remember previously we had like that 500-line file that just defined a few types. Well, if I go in and look at multiply request now, then our generated code, yeah, it's not like the smallest code ever, but this is now the generated code from that .proto file, and it's a lot more obvious what it's doing. It's just an X. Here's exactly the same as we had pretty much as the one we wrote by hand. It's now using Protobuf-net's attributes, but the library will accept a whole range of different attributes as long as it's kind of good enough for it to understand what you mean. It'll take it. It's very forgiving. So yeah, the tools to actually work from .proto schemas do still exist and do work. And for my mind, that's now 40 files, 40 lines, including the pragmas, rather than 400 or plus lines. So that's a good saving for me in terms of simplicity. So the streaming is much simpler when using the IAsync and removal of T. And we no longer have to ship or rely on the CHTP2. Unless you're not on .NET Core 3. So you can pick and choose your poison there, but it's an option. So to kind of wind up really, I think gRPC is a great tool for general purpose call between services, especially for microservices where every bit of latency adds up between all those different hops, and you want the efficiency does start to matter at scale. I mean, efficiency is money. Whether you're paying for cloud CPU or network in and out of services, if you're doing it on the cloud, you know how expensive. Just halving your bandwidth things can really matter. But even if you're in your on-site own hosted things on Metal, there's a difference between needing 3 servers and needing 6 servers. So anything you can do to kind of reduce your cost is good. By default, it takes a little bit of effort. With GRPC, so this is using the Google tools, there may be some ways to make that easier if you're happy to take external libraries with hit and miss support. But with .NET Core 3, Microsoft fixed a whole range of the problems. Well, I say problems, that's not the right word. There are wrinkles, there are things that make gRPC slightly awkward, and the fixes that Microsoft and Protobuf-net provide get rid of some of those pain points. The gRPC is good, there's not problems, that's the wrong word. And everything's now RTM, so you can play with it. So really, please feel free to come and talk to me. I can talk about this stuff for hours, although Dan may be throwing me out the door. But I just wanted to say, a big thanks for coming and listening to me. I hope I've kind of at least whetted the appetite of a few of you to go ahead and think maybe this is something I should explore. And if you go ahead and have a look at it and decide, actually it isn't the right tool for us, that's fine. If you go ahead and look at it and it is, great, have fun. I view kind of my job when I'm kind of talking at these things is to just kind of show people what tools exist, and then you can pick and choose whether that tool is right for kind of your system. I'm not saying it's the best thing and you should use it in every single system. That would clearly not be the case. But it is a good tool, and I hope you can use it. So, thank you.